Hey, hi everyone. Very good evening. Hi, Jagdish. Good evening. Hi, Anil. Good evening. All right. So, is my voice is loud and clear? Is it loud and clear? Hi, Harsh. Good evening. All right, Anil. Fine then. So, let's get started. So let's do a quick recap and then we'll get into today's topic. So, what are the topics we have covered yesterday? Can you just post one by one? And if I give any task, you can also post along with it. What are the topics we have covered in yesterday's session? Oh, wonderful, Anil. I think you are already prepared. Great. So, data visualization, Python-based visualization libraries, Matplotlib, Uni. Oh, wonderful. So, Anil, well prepared, Anil. Appreciate it. Srisha, right. Hash data visualization. Pavani, I think you're also prepared before the session. Wonderful. Seaborn, Matplotlib, Plotly. Great. So, histogram and so on. Let me ask you some questions. You can just let me know which chart we have to pick it up. All right. To understand the quality of continuous versus continuous, I'll pick up which chart. The charts, whatever we have learned yesterday, you can just give me the terms. So one continuous plus continuous. I want to understand the relationship between one continuous versus another continuous variable. I'll go with Howlett Jagdish. Wonderful. Good to know that. So I want to understand the quality between one continuous and another continuous variable. I'll look into which graph or which plot. Renuka wants sync on it. Harsh, Jagdish, wonderful, great. What about others? Can I get responses from everyone? Everyone can participate on this question and answers in the first few minutes. Okay, Harsh and Jagdish said it is scatter plot. Wonderful. So to understand that quality between or the relationship between all the features at once I look into. Srisha, what is that man plot, Srisha? Something new plot, I'm hearing it for the first time. Okay, I think that was typo mistake. Harsh and Jagdish, yes, pair plot or heat map. Wonderful, Renika. So I want to understand the distribution of one discrete data. So I look into what? I want to understand the distribution of one discrete data. one discrete data. Chaitanya, question is one discrete data. That's it. Renika, here you're right. Srisha, you're right. Jagadish, Harsh, and Pavani once think on it. I want to understand the distribution of one discrete data. Univariate, yes. I'm asking about the plot and hi Supriya, good evening. Srisha, yes, you're right. Pavani, once think on it. Histogram, hi Aditya, good evening. Histogram, is it to understand the distribution of one discrete data? So to understand the distribution of one continuous data, I look into what? Yes, Supriya, great. Continuous data is histogram. Pavani, wonderful. Renika, yes, histogram. Continuous histogram. Right, Vasil. Wonderful. I think you're good good with choosing between this particular data, sorry, multiple charts. In case I feel if you're exploring new charts by your own, you should be able to understand what type of data we have to give it and everything. So when I'm giving one discrete and continuous data, I'll go with what? Discrete and one continuous. It's okay, Aditya. Today's topic is pretty new. There is no continuation from yesterday's topic with today's topic. Renika, one discrete and one continuous. Can we use scatter plot? One second. Srisha, right. You're right. Pavani, yes. You're right. You got it. Harsh, yes. We can use that plot. We can also use box plot. Um, have you all read about this box plot, pie chart, and everything? I have not covered that yesterday, but did you all get a chance to explore any other charts? If you have explored, can you just name some of the charts on the chat box? In case. Great, Supriya. Wonderful. All right. So no responses. Fine. But see this. This is how the scatter plot ExcelR should be done. Yes, Supriya, great. So this is how in case if you're enrolling for this program with ExcelR, 3 months, every day it is going to be a new topic. All right. So even if you miss one day, it is going to impact your next day's learning because I would daily give some tasks and I will occupy you, I will engage you, I will demand more time with respect to this while learning. So if you enroll to this program, make sure your mindset should be ready. It is not something like a very easiest program that we can complete. Yes, it is easy if you are giving more time to complete it. So but I think whatever, in case if you're giving complete time here, I think whatever we are learning the session is more understandable, right? Whatever we are learning the session, is it understandable? Yes or no? Is it complex to understand? Understand. All right. So this is how wonderful, Pavani. So this is how the session will be. All this 45 days, it will be daily new topic. Daily, I will be giving some tasks. It's nothing but if you are giving If you are giving more the time, whatever I'm just saying in the session, to go through it by watching the recording, lot of groundwork is required. So behind the scene, if you see someone who's able to get placed within 6 months or 8 months, every day it is going to be a learning. All right, you can just spend only one day in 1 month or 2 days in a month to just have a leisure time. Apart from that, so it's continuous learning. So I know one learner who's from civil background, and she post completion of this program, she used to come to the institute. She used to visit our institute and used to be there from morning 9 o'clock till evening 7 o'clock. So then why she need to be there post completion of 3 months of course, and she was there for another 3 months. So by the next third month she got into the job. So the point is nothing but during the training program and after that, that's what the timeline, 6 to 9 months time period. So that's what the timeline to make a successful career transition into this particular field. And again, 6 months it's minimum. Within there are 50 months, so there are some learners who got into the placements and everything. But this is the time duration, 6 months to 9 months. That's so come each and every day it is going to be continuous learning and everything. So it's all about not me, how I'm just delivering the training. So training is something anyone, you can just learn this kind of training from this internet. If you're giving some time, you can learn it. But the point is nothing but how much you're bending yourself, how much you're spending time on listening to this lecture and practicing. That's what really means. So try to give more time here if you're very serious about making a career transition into this profile, which is going to help you. Is it making sense of what I'm saying? All right. So now let's get into today's topic. So let me do a quick recap on the things what we have covered till now. So we just understood about that we just started with the life history of a data scientist, sorry, AI, the brief history we looked on to it, and then we have discussed about this life cycle of a data scientist, and then Python framework, sorry, Python basics, we worked on it, and then Python data structures, and then we worked on Python libraries, which is nothing but pandas, and then we got into Python visualization, that is data visualization with Python libraries. That's what we worked on yesterday. So now today we are going to get into the next topic, that is statistics. All right. So now why we need to get into statistics. So we are going to start from there. And today's session is going to be more theory and external list. 1 minute. Is it fine now? Is it fine now, Dr. Leila? You can let me know. Okay. So today we are going to get into the statistics part 1. And next Monday, we will be continuing the next part of statistics. So today's session, it is going to be more theory. We can say only theory, and you can just take notes if you want, and we can get into this session. So let's get started. So now why we need to learn about the statistics? I'm just getting a question. Now, why we need statistics is nothing but the major key we can say to make a statement about present. So I want to know what decision I have to make now. For that, I need to get into statistics. For example, we can say, let's say here we are having Amar and Anil, right? So let's say Amar and Anil I'm having here, and they are what they want to do. There is a business case where exactly in one, let's say in Bangalore we are having one area called as electronic city. So maybe in Maharashtra you should be having one particular place. Let's say it's a metropolitan place. So there we have to open up one ice cream shop. Let's think about this. So we have to open up one ice cream shop. Now Amar and Anil, what they are doing, let's say they are good rich persons. So they are having good amount of money, and they just they wanted to be a partners. They just got together and they just invested their money, and they got some ice creams and they placed it on their particular store. This is case number 1. And now there is another team where we are having Pavani and we are having, let's say, Renuka. Pavani and Renuka, they are team number 2. Now, what Pavani and Renuka they are doing before opening up, they also wanted to open up an ice cream shop in the same area. But before opening up the shop, they both are just going to that particular location and they are collecting some data. Let's say they are just reaching out to 500 people and they're trying to ask some questions like, hey, we are going to come up with this ice cream store. So which flavor do you like most? And what is the price range that you would be buying it in case if you're coming with this particular product? So in this way, so so this team to Pavani and Renuka, they both are trying to get some data. And then they just and they looked onto it. They have seen which customer, what is the most interested product people are trying to get it and everything. So they are looking into it and they're just buying it. And then what is happening? So after let's say after 3 months, or after 3 months, so or we can say whose stocks is going to be get completed within 1 month or 2 months. What do you say? Whose stocks is going to get completed soon? In next 2 months, Pavani and team 2 or team 1? Team 2 or team 1? Whose stocks is going to get more completed soon? Srisha, Supriya says team 2. Jagadish, team 2. Yes. Why team 2? We all know it is team 2 because team 2 have they both have studied about this market. Okay, what is the central value? How much price we have to keep? Because they have gathered the data and they looked onto the central value. Because in case even whenever we are delivering the training, I can't the trainers can't go and please every learners, right? So maybe some of you will like the training, some of you will not really like the training. You are forced to attend this particular lecture because of your faculty's pressure or whatever it is. Let's take it, but you're not able to understand what I'm saying and you're giving a very pretty bad feedback that whatever I'm speaking, it is not at all understandable. So I'm getting some responses. So the point is nothing but what the ExcelR will consider, or who, let it be whoever the management team, they look into the most most of the feedbacks. We can say most of the people are able to take it or not. That's what they will be looking into it. Obviously there will be some outliers. Outliers is nothing but we can say some 1 or 2 people or 1 or 2 learners who's not going to get it. So again, they will be looking into why they are not able to get it and everything. But to understand how well the training is going, most of the people are telling what, right? So that's what it is going to happen. Let's say in a classroom and you're having 50 people and out of 50 people, 48 or 45 people are not at all attending the session. Then how can the teacher or the staff can come and take some trainings or the lessons? It is something very difficult, right? So in the similar way, what is the majority of the people are liking which particular flavor and what is the price range they are trying to get it? So in this way, I'm just trying to, but it will take time for the survey comparatively. Yes, Dr. Leela. So that it will take time, but the point is nothing but I'm having some set of money. At the end of the day, whenever I'm just going for the business, I will expect a huge profit within the shorter period of time. So now whenever I'm just opening up a business, if the stock, if it is available for 3 months or 4 months, then I need a profit within a very short span of time. I need a profit. So for that, by collecting the data, by looking into the central value and the price range of all this particular detail, now before opening up the shop, now I'm just getting to know, okay, what decision I have to make now, which stocks I have to get more, which stocks I have to get more. For example, by collecting the data, out of 500, I'm able to see for 400 people are liking vanilla and 550 people are liking strawberry, 50 people are liking chocolate. I will get accordingly more stocks. I will be investing on vanilla, less stocks on vanilla, less stocks on strawberry, less stocks on chocolate, and maybe if I wanted to come up with something new flavor, I will just get only few, so that if people are liking it, I will get more. But most of my stocks it will be with respect to vanilla. So based on that, I will be investing my money to get some stock, so the people are going to commit, and very soon the stocks are going to complete it, and I will be also getting a good profit. So compared to team number 1 and team number 2, their stocks is going to get completed soon, and they will be getting a good profit soon. So repeating this process again and again, I will be getting good profit. So at the end of the day, statistics, that I've collected the data and I looked onto the central value. Most people are liking what and everything. So this data is going to help me to make a decision now, which stocks I have to invest on. For that, we need to get into statistics. Able to get my point? All right. So again, whenever I think you all got it. So again, within statistics, we used to speak about different terminologies like sample, population, and everything. So I think you should be, heard about these particular terms. Let me ask you this question. So population versus sample. What do you think the difference between population and sample? Population and sample. I'm not sharing any screen. I'm just raising some questions, and I will be sharing in a while. What is the difference between population and sample? Dr. Leela says population is set, sample is a subset. Wonderful, Dr. Leela. Population, the whole data, is Dr. Veera. Anil says sample specific, right? So Chaitanya says sample is a trial taken from the population. Right, Chaitanya, great point. Harsh says population is huge data set, sample is small part of it. Dr. Veera says, again, sample random data from the whole population. Right, perfect point. Jagdish, population is the total number from which data can be collected, and sample is the numbers which sample has been collected. Okay, great. Introduction to statistics. Great. We can say the entry point, the welcoming people. Sample is from population which we want to analyze. Right. Wonderful. Great point, Supriya. Sample is from population which we want to analyze. Great point. So great, Amol. So the point here is nothing but I think everybody knows about this particular term sample and population. Now, the similar way, even let me give you one particular definition. So always we can't get this. Which one is more powerful, population or sample? What do you say? To make a statement, which one is more powerful? Sample and the population. Okay, both sample. All right. Let me ask you one question. So I want to know. I want to know, let's say here we are having Renuka. Now Renuka is cooking a very good mushroom biryani, let's say mushroom biryani. Now I want to understand how exactly the cooking means she prepared it. It means we waited, we are just waiting for a good lunch. And now I wanted to see how exactly this mushroom biryani is tasting. So to make a statement, how exactly this mushroom biryani is tasting, will I eat the complete biryani and say the mushroom biryani is tasting good or a small portion? What do you say? I just want to know the taste of mushroom biryani. Dr. Leela says a spoon of it, small portion, right? Small portion is nothing but what? Sample. So to make a statement, I don't need to, yes, population is something we have to make a statement upon. How exactly the entire biryani is tasting, that's what the statement we have to make it. But to make a statement, so we can't eat complete biryani and say how exactly it is tasting, right? So that is the point with respect to this particular sample. Why we need sample? We can't get all the population. Let me try to ask you some other question. Let's say I want to understand here, since most of you are all from Maharashtra, let me ask this question. So I want to understand the average mm, average height of Maharashtrians. Let's take it. Average height of Maharashtrians, I want to understand. Is it possible for me to go and reach out all the people or all the doors who are living in Maharashtra to make a statement? To make a statement that is the average height of Maharashtrians, I want to know. Is it possible for me to go and reach out to every doors? So, but what I will be doing, maybe I'll just, let's say in Maharashtra, we are having to 300 cities. Now I will just visit to first city. I'll try to reach out to maybe 150 people, second city, 150 people, third city, 150 people, even that 150 people from each and every city, it's a sample. So what I can do is nothing, but I can always reach out to sample and finally I'll aggregate it and I can come to one conclusion. So reaching out to the entire population, it is not something which we can do. It is a time consuming process. And by getting a sample, we can analyze some set of, we can do some operations with respect to the sample and we can come to conclusion and we can make a statement on the population itself. That's what the power of sample. So we can't rely on this particular population all the time because we don't get it. Population size is so huge. So what we are doing, we are collecting, we are depending on the samples to make a statement on the population. That's the need of sample. So how exactly this sample should be is nothing but see this. Now let me share my screen. See this. Sample versus population. Sample should be equal to population in lines of properties. All right, very important point. Sample should be equal to population in lines of properties, but it can vary in size. So population size can be huge, sample size is small. You can think of this biryani example, what I've said. Population size is so huge, enter biryani. Sample size is small. But how exactly this sample and population should be, it should be equal in lines of properties. Or if I'm tasting it, if I'm saying, hey, this biryani came out well, which means that entire biryani has came out well. So sample should be equal to population in lines of properties, but it can vary in size. Now, why sample? Because we are unable to knock the door of the population all the time because population size is so huge. And one more point here I just mentioned, sample collection is purely dependent on the domain knowledge. Now, what exactly it is, let me stop sharing my screen. Let me give you another example. Let's say here I'm having, let's say Justina Michael. Now, let's say Justina Michael is a bank manager. Let's take it in this way. Now, let's say here we are having Srisha. Srisha is a customer or client who's visiting Justina's bank. And now Justina wanted to, now Srisha wanted to know whether she's eligible or not eligible for a loan. Now, Justina need to probe right questions to Srisha. Hey, what is your salary? What is your CIBIL score? Have you taken loan amount or previously or not? If yes, how much the loan amount? What is the pre-closure amount? How you have just paid? So to know more about Srisha, Justina should probe right questions. Now, Justina, if she wanted to probe right questions, so she should be good with raising questions, which means that she should be good with understanding that particular domain. She should be good with that. So that is the point here. Now, when I'm trying to get some sample from the population, or we can say from any customer, so we have to be good in that particular domain. So let's say we wanted to come up with come and prepare a good biryani. So from entire chili powder, I need to pick up only some sort of sample. From entire coriander powder, small sample. From entire chicken biryani powder, sorry, means meat masala or whatever it is, I have to pick up some small set of samples. So this sample, how much quantity to pick up, is completely dependent on the experience and the domain knowledge. So that's the same point which I've just mentioned here. If you see, sample collection is purely dependent on the domain knowledge. If that's, and only then your sample will be equal to population. Able to get my point what I'm saying? All right. Fine then. So now let's get into the details. All right, Narayan. So see this. Now let's say now we understood the purpose of statistics. Now sample versus population we understood. The need of sample we understood, and for sample collection we need to have a proper domain knowledge. We learned it. Now let's say we got some particular data. So to understand the data that I've collected, let's say even if we think about the ice cream example, what we have just learned. So we have collected data from 500 people. Now, to understand the data that I've collected, or to understand the sample that we have collected, we look into something called as EDA. We call it as exploratory data analysis, the initial investigation. We have already performed this by using the shape attribute and describe function, everything. We already learned about this. Now again, we are coming back and we are just looking onto the things. Now see this. Now here, we got this particular population, right? So we are having our population in our hand. From the population, we are getting some set of samples. So now to understand the sample more, we are going to perform something called EDA, Explorative Data Analysis. Now within this EDA, we are having four things. One is measures of central tendency, measures of dispersion, normal distribution, skewness, and kurtosis. So these are all the four different things which is available within your ED, Explorative Data Analysis. Now, what is this measures of central tendency? Within this measures of central tendency, that is the central value, we are having three divisions. One is mean, median, and mode. Within measures of dispersion, we have variance, standard deviation, and range. And then we will be discussing about normal distribution. And then we will be discussing about skewness and kurtosis. Now let's go one by one. That is measures of central tendency. So now you collected your complete data, 500 data you're having in your hand, right? So now see this. Let's start with this. Now, what does this mean? I think mean is nothing but normal average. Median is nothing but the middle value. Mode is nothing but the most occurring value. These are all the three terms. You can note it down. Mean is nothing but simple average. Median is nothing but the middle value. Mode is nothing but most occurring value. Everything is coming under measures of central tendency. Now, how do I choose between mean, median, and mode? Which one to choose first? Based on what I have to choose it. Now you can just look onto this particular example. See this. Now here I'm having this particular thing. Where exactly, let's say here I'm able to have maybe Nabila. Let me take Nabila. Yes. Let's say here I'm having Nabila here. Now let's say Nabila has given examinations, and for first exam she got a score of 100, and physics she got a score of 100, and math 100, English 100. But the fifth exam, because of some illness, she did not appear to the exam, and because of that maybe absent. But when we are mentioning it in paper, AB will give it, and when we wanted to find out the average for the total marks, we try to treat it as 0. So I just given 0. Now sixth exam she appeared it because she got well. Seventh exam appeared, but again she fell sick, and again she appeared it. Now I want to know the average marks scored by Nabila, which is nothing but the simple average. 100 plus 100, the total 10 hundreds divided by 10 if you give it. Two values are 0, so it is nothing but, and mean is nothing but the simple mean, or the simple average is nothing but 80%. Now median is nothing but whatever the values we have, we try to arrange these values in ascending order or descending order. Any order you can do it. All right. Here I've just arranged it in ascending order. 0, 0, I've just given it, and all the values are given. Now, since we are having even numbers here, 10 numbers, even numbers, we try to take middle two numbers and try to take an average. If it is 11 subjects, what is the middle number? From 1 to 11, what is the middle number? What is the middle number? It is 6. So if the total number, if it is odd, we can pick up the middle number directly. But here the total number is even. I can't pick up a number 5 because 5 is nothing but above 5 I'm having 4, below 5 I'm having 5. So that is not the middle number. So what I do, I'll just take the average of the middle two numbers. What is the middle two numbers here? After step number 1 is nothing but arrange your data in an ascending or descending order. Now here I arranged in descending, means ascending order. So now the middle two values are 100 plus 100. So 100 plus 100 divided by 2, it is nothing but the middle value is median, 100%. Now, what do you think is the true value, true central value? Means we can say, what do you think the right average for Nabila? Do we go with mean or we need to go with median? What should be right? Mean or median? Okay, Jyoti mean, Jagdish mean, Pavani mean. Okay, Glanny, Dr. Veera, everyone mean. All right. Let me ask you this question. Let's say Glanny has appeared to this examination. Okay, Glanny instead of Nabila, maybe Nabila should say Not getting response from Nabila. Not sure about Nabila's mindset, but maybe let's say Jyoti, since Jyoti is responding. So let's say Jyoti, you're giving some examination, and what would be your mindset? Hey, finally you're getting to see the average. So what would be your mindset if I'm saying your average marks is 80%? Any person, just think in your lines. What would your mind think in case if I appear to this examination? Hey, definitely I would have got 100 marks. Then my actual central value, it will be 100 marks or 100 percentage, isn't it? Yes or no? Right. So the point here to be taken is nothing but here these two zeros are totally misleading this right central value. That is nothing but, so this we can say we can call it as an outlier. The most extreme or the most least value, we call it as an outlier. So to understand the right central value, so always for data analysis, we try to exclude this outlier and we try to take it. In case if we don't have it, let's say 95, 95, we are having it, we can just go and pick up with mean because it is only a very little bit variation. But when all the numbers are like 3-digit numbers, and here I'm just going with single digit number, which is very less compared to all the other values, we call it as an outlier. So when we are arranging the numbers with respect to arranging, ascending or descending order, I'm only looking into the central middle two values or the middle value to know the right central value. So in case if you're having outliers, we call this particular zero as outlier. In case if you're having outliers in your data set, to understand the right central value, we go with median. And if there is no outliers in your data set, we try to go with mean. So in the presence of outlier, median. Why? Because we try to arrange it in ascending or descending order, and then the central values will try to pick it up to understand the right central value. If there is no outliers in your data set, we can go with mean. Is this point clear? Jagdish says, for example, if Ms. Renuka got the data for ice cream price, everyone has given the rate from 50 to 100. And if someone is giving rate rupees 1, it's called an outlier. Right. You got the point, Jagdish. Perfectly said. Now I can't keep the rupees 1 because most of the people are giving 50 to 100. I can't go with 1. That is something only 1. So should I go and please 1 or other people, all the other learners? Sorry, yeah, other people. That's what the point. All right. So now we understood how to choose between mean and median. Now, what is this mode? Mode is nothing but, let's say here, I think I did. Okay. Mode is nothing but we can say most occurring value. Let's say here, let me ask this question. So here I'm able to see, let's say Jagdish, Harsh, and Dr. Veera. Now I want to understand most of my learners are from which location. Let's say Dr. Leela is from Chennai, Dr. Veera is from Mumbai, Harsh is from Mumbai, and Jagdish is from Mumbai, and also let's say Jagdish is from Chennai. So and Jyoti is from Chennai, and Srisha is from Chennai, and Glani is from Chennai. So here I think I've just listed some of the locations. Now, most of my learners are from which location? Most of my learners are from which location? Which location? It is Chennai, right? So when the data, it is something like categories, all right? Mostly we don't try to take mode with respect to numbers. We try to take mode when the data fit is something like a discrete data or a categorical data. So most occurring value, that's what the point. So even if you take, for example, ice cream example, what I've said, most people are trying to look into which flavor. So I will just go with mean, median, or mode. Oh, is it so simple? Okay, yes, you got it. To know which, for the ice cream example, which ice cream has been occurred most. So I'll just, to know the central value, I'll choose mean, median, or mode. All right, it is mode. So based on the again the type of data, we try to choose between the things. All right. Is it median, Nabila? Is it number? It is vanilla flavor, right? So it is a discrete vanilla, strawberry, butterscotch, pista. It's a different flavors. So it is a mode there. Got my point? Yes. So it's mode, right? Fine. So now I think you are good in understanding choosing between the central values, mean, median, and mode. Now let's get into the second part, measures of dispersion. Now, what is this measures of dispersion? We need to understand. So within this measures of dispersion, we are having three things. One is variance, second one is standard deviation, third one is range. Now, again, the most used one is nothing but standard deviation. We use it for a reason, and we don't even use variance and range in most of the cases. Why? We will understand it now. Measures of dispersion. Measures of dispersion is nothing but we understood the central value. Let us take it think in this particular way. Let's say Dr. Leela is handling let's say electronics and communication second year students. All right. Now she wanted to report to principal or the head of departments on the average marks scored by second year ECE students. Now the average marks is nothing but the central marks, right? The center point. Let's say the average marks is coming around 75%. 75% is the average mark scored by second year electronics and communications class. Now, does it mean that everyone scored 75 marks? Does it mean that everyone scored 75 marks? Because that is the central value, right? Anyway. No. So maybe some of the people have scored less than 75 marks. Maybe we can say 55, 60, or for some even 45, some even got failed. And some of them might have got 76, 85, 90, 95, or 100. So from the central value, that is 75%, how much my values got deviated to the left and to the right. So that's what this point which I just mentioned. I want to know how well the values got deviated from the central value. That is nothing but the mean. We will be getting into variance, standard deviation, and range. Now, let's get into this particular part. How we are going to calculate this variance. See this. Now here you're having this information. That is, to calculate here you're having, let's say my age. Let's say here I just calculated totally 10 ages. Age of my learners, I've just calculated it. So totally, if you see the count, it is totally 10. Let's look out to the bottom. It is totally 10. All right. So totally 10. I've just collected age of my learners, and then I'm just calculating the normal mean. Just average. I'm just collecting it. Now I want to know the central value is. The central value is nothing but 36.5. Now I'm saying the average age of my learners is 36 years. Maybe we can round it up and say 37 years. Now from this 37 years, how much the values got deviated? I want to make a statement. For that, what I want to do. So here I'm just using this particular variance equation. It's nothing but this equation, which is denoted by sigma square. Summation is nothing but XR. That is that particular row. Let's take it 28. 28 minus mu is nothing but it is speaking about mean. Mean is nothing but what? 36.5. 36.5. It's summation. So the whole square plus summation at second term. 27 minus 36.5. That is a mu. The whole square plus again 25 minus 36.5 the whole square until all this observation I do and divided by n is nothing but the total number is nothing but 10. Finally, I will be getting some answer. Let's say it is 10.5. The unit is what? Years. Years square I'll be getting it because in the numerator you're squaring it, right? 28 minus 36.5. Then whatever the answer, you're just squaring it. Now the unit is nothing but 10.5 years square. Now to make a statement, to make a deviance and everything, do we say 10.5 years square to understand the deviation? Let's say you are traveling between Chennai to Bangalore. Okay. Now I want to understand. Let's take one center point. Okay, the center point is nothing but, let's say, maybe Krishnagiri. There is one place called Krishnagiri. So from this particular center place, I want to calculate the distance. Now, will I say the distance is 150 kilometers square? Is it a right term? The units. The distance is 150 kilometers square. No, the unit is not something right. We don't say kilometer square never. We say it is kilometer. So just to normalize this particular units, all right. How to normalize this units? I have to take a square root. So I need to take a square root on the right hand side. See this? To this particular equation, taking square root here, and this variance also I'm just taking square root. So this square root and this 1 by 2 and 1 by 2 will get cancelled. So sigma is nothing but square root of summation of xi minus p the whole square divided by n. That is what standard deviation. So to normalize this units, now I'll be getting years and 5.5 something I'll be getting. So the point is nothing but this is not 5.5 basically, maybe the other number, but I'm just focusing only on the units. So how do I choose between variance and standard deviation? That's why I said variance, we don't use it much because of the units, it will be something like squared units. So in variance, units will be in squared terms. Why standard deviation? In order to normalize the variance, we get into standard deviation. And range is nothing but just know it. There is something called range. The range is nothing but maximum minus minimum value. Let's say you're having even the same example. If you think I want to understand the deviation, what is the minimum value here? Maybe the maximum value is 80. Minimum value is 22. 80 minus 22, you'll be getting something like 60, maybe 78 or something, right? So some number you'll be getting it. So that particular number is the deviation. That is nothing but again that will give an idea what is the minimum and the maximum value and what is the deviance. But that is not the perfect one that we are trying to see, because the deviance will be very high. So just to know what is the minimum and the maximum value and what is the difference between this, again, in one perspective, it is a deviance, right? It is a dispersion, but it is not trying to take the central value and trying to make up the difference. So it is just a range minimum minus maximum that is going to give it to me. But all the time from the central value, if you want to calculate it here, since we are including mean, which is nothing but the central point here, we always try to go with standard deviation rather than variance and range. Able to get my point what I'm saying? Wonderful. So from the central value, we need to calculate the deviance. So that's what the point. That's what here I just also mentioned it. Okay. To normalize the variance, we get in a standard deviation, and the variance and range, just know about it, what exactly it will do. And one more point also here we have to consider. Let me stop sharing it. 1 minute. One more thing about this variance also we need to understand in this perspective as well. Let me share it again. So here if you see, all right. So here I'm able to have some data. That is, here I'm having, let's say, this is, let's say it is Jyoti. All right. So this one is, let's say it is Anil. And here, Dr. Leela is a project manager, and let's say Dr. Veera is a team lead. Let us try to understand this way. All right. Now here, if you see, this is maybe an IBM company. We can take it in this way. Now, Jyoti is reaching to this IBM company Monday at 7 o'clock, morning 7 a.m. Tuesday, she's reaching at 7:10. Wednesday, she's reaching at 7 a.m. Thursday, she's reaching at 7 a.m. All right. And I just want to understand these two questions. So Friday, she's reaching at 7:10. Now, let's say maybe Dr. Veera, means Dr. Leela is asking Veera, hey, when this Jyoti is going to reach office, I just wanted to meet her, I just wanted to appraise her for her work. Something, just there's a conversation. Now, Veera is looking into her history. When is Jyoti is reaching the office? Now I want to make a statement. When this, when Jyoti is going to reach office on Saturday. So what do you see? What do you see? 7 to 7:10, maybe. The central value, just take an average, maybe you'll be getting 7 or 7.5, something like this, right? We can just give a figure around 7. We are pretty good with it. Now let's take Anil here. On the other hand, Anil, Monday he's reaching the office at 7 o'clock, Tuesday at 9 a.m., Wednesday at 12 p.m., Thursday at 8 a.m., Friday at 8 a.m. Now, can you just give a confident statement like when Anil is going to reach the office, the way how you have given for Jyoti? Are you so sure? Maybe in case if you say central value take in average 9, but you're not sure about it. Why? Because every day, right? Everyone all right. Because every day it is different timings. So here if you say for Jyoti it is less variance, and for Anil it is high variance. Less variance is nothing but from the central value, it is only very less variance. But here with respect to Anil, from the central value, just take an average, you'll be getting something like 9. Let's take 9. From the central value, the variance is high. So the point is nothing but when the variance is high, always it is a bit difficult to make a statement. It is very challenging. And when the variance is less, we can make a statement. Let me come up with an example. Now, Monday, Tuesday, Wednesday, Thursday, Friday. After Friday, what day it is? It is Saturday, right? So we know that. Is there any variance there? To make a prediction, is there any variance? Zero variance. Everybody knows that. Now let me say, for example, what would be the weather tomorrow? Maybe you can just give a figure. We can't assure what exactly the temperature exactly it would be because of higher variance, right? Maybe we can give it, but again, we can't give 100% confidence the way how we have given for the first case. After Friday, it is 100% confident. So the point is nothing but we are dealing with some randomness in the data. So again, if there is no randomness, that's what tomorrow you'll be learning it. This is the same point I'll be mentioning in, tomorrow. If there is no randomness in the data, there is no need of data scientist. Okay, let me repeat it. If there is no randomness in the data, no need of data scientist. What is that? Because everybody knows what exactly, everybody can make a prediction. Even a small kid, first standard kid can say, after Friday it is Saturday. Now, why we have to hire a data scientist to make a prediction like that? So as a data scientist and as a data analyst, so we try to deal with some randomness in the data. So randomness in the data is the root of all the probabilities. Let me repeat it. Randomness in the data, we can say it is the root of all the probabilities. So we'll try to get into it more by next Monday, what exactly, and we will be dealing with some randomness in the data and everything. But the point here to be noted is nothing but whenever we are dealing with a high variance in the data set, it is going to be a bit challenging to make a statement. That is the same point here, I just mentioned it. If you look onto it, if the variance increases, that is from the central point, if the variance increases, the quality of prediction decreases, which means that it is not like it will be very poor. It means that you can't achieve 100%. 100% prediction, you can't achieve it. Able to get my point? All right, fine. So now let's move further. So I think we are discussing about statistics. It's all making a statement about present. Today it's going to be completely theory. Now again, let's look onto this. So we don't get the complete population in our hand. We get only sample, and to understand the sample more, we are looking into the central tendency, mean, median, and mode. And to know measures of central dispersion is nothing but from the central value, how the values got deviated. We are getting into this measures of dispersion. Now we are going to get into normal distribution, skewness, and kurtosis. Now, what is this particular normal distribution? Is nothing but whenever anyone heard about this term normal distribution? Normal distribution, I think you should be. What is this normal distribution? Any idea? Can you just post it? I think in day one, I remember most of you are from commerce background. You should be understand. You should be explaining this the term now. What is this normal distribution? Great, Jyoti. More technical. Continuous function. Great, Amma. And even if you're studying the statistics paper and everything, so statisticians used to say most of the data should be normally distributed. Let me give you some clue here. See this. Even our life follows probability distribution used in statistics. Great, Mohammed. Even I say this our life follows a normal distribution. For example, since I know everybody know how exactly this normal distribution will look like. So here let me take. Okay. Here let me take this my x-axis. X-axis maybe let me take age. All right. I'm taking age here. Age in years. All right. In y-axis, let me take dependency on parents. All right. Let me take dependency on parents. Yes, I'm all right. So dependency on parents. Now, when we are as a kid, we don't know whether we are dependent, means how exactly we are getting to realize. So when we are here, the age is let's say 1, 2, 3, 4, 5. You can just think about it. All right. When we are like 0 and let's say 1 year and 2 year, we don't know whether we are dependent or not dependent on the parents. But when exactly when our age is slowly increasing, we are getting to know that hey, we are completely dependent on our parents. So when age increases slowly, our dependency on our parents, let's say school and colleges and everything, they are just paying the money. So our dependency on our parents is slowly increasing up to one particular level. Now you have completed your graduation. Now slowly you got into the job. Now slowly what is happening now, let's say if you got into some let's say BPO calls or whatever it is, again if you are getting paid only for 5,000 or 10,000, again there will be a little bit dependency from your parents initially. But what will happen, slowly your dependency from your parents will come down. Dependency from your parents will come down, and it will just gradually reduce, and at one point in time there will be no dependency of your parents in terms of money. All right, I'm just speaking about only in terms of money, not the emotional support and everything. So after this, your dependency from your parents will come down. So this kind of curve, we call it as a normal distribution curve. This we call it as normal distribution. Our life follows this normal distribution. The life phenomenon itself a normal distribution. So let me repeat this example, what I'm saying. So we don't realize whether we are dependent on our parents up to one certain level. But after a certain age, we come to realize that hey, we are dependent on the parents slowly, and when the age increases slowly, they are paying more money for our colleges, more dependency, and then up to one particular after that, once you got in the shop, then slowly your dependency level comes down, and then there is no dependency at all. So this kind of bell curve we call it as normal distribution, and it has a lot of other names. We call it as normal distribution. We call it as Gaussian distribution. Normal distribution, Gaussian distribution, both are same. Gaussian distribution, or we call it as bell curve, or it's an inverted bell, we can say bell curve, and we can say it is also symmetric. It is symmetric around mean. All right, symmetric around mean. So these are all the other terms of this particular normal distribution. We call it as normal distribution. Sometimes we call it as a Gaussian distribution. Sometimes we say, hey, it's a bell curve and it is symmetric around mean, we used to say. Standard distribution, there is a difference between standard distribution and normal distribution. I'll come back to that point. That will be pretty challenging to understand, but we'll arrive there. Just wait for a while. Fine. Now, see this any example you can think about it. So this curve, let me just replace this particular line. And if you're getting this kind of data, if the data of it is something like a normal distribution, we can come to a conclusion we have collected the complete data. For example, let's say here, let me erase this thing. Let me come up with some other example. All right. Let's say here, here I'm having, let's say, let's say Jagadish is there. Now let's say Jagadish wanted to buy some, let's say Jagadish here, he wanted to buy one mobile phone. All right. And basically his price range is nothing but 15 to 20,000. That's what his price range. But what he's doing, he's just referring his friends and everything. They are just giving a figure. Here we can take it as 0 to 5,000, 5K. He is getting very less, 1,000 to 5,000. And he is getting maybe 10,000. And he is collecting more data between 10,000, 15,000. 20,000 is getting it, and 25,000, and 30,000, 35,000, 40,000, everything. So if you see, most of the phones are between 10K to 30K. But what he wanted to buy is nothing but 15 to 20K. So now, if I'm just giving only the idea about here it's y-axis nothing but frequencies. The number of mobile phones here, y-axis always speaks about frequencies, actually with respect to normal distribution. Now, here, when he wanted to buy 15 to 20K, but I'm just giving a complete figure. Let's say below less than 5K, I'm just giving some ideas. And 5 to 10K, again, the number of mobile phones I'm just showing is nothing, but this, let's say the frequency is a bit higher. 10 to 15K, bit higher. 15 to 20K, more. 20 to 25K, again, this many. So 25 to 30, so that he is going to get a complete idea how exactly this mobile phone is working. So when the data of it is following a normal distribution, it will give us an idea. We have collected the complete data. All right. To make sure whether we have collected the complete data or not, if the data of it is following a normal distribution, we can just come to this particular point. Why you have to collect the complete data? Only then we will make sure we can make a good statement, right? We can make a stable statement, because he wanted to buy 15 to 20. But in case if I'm educating him with respect to all the other products which is available, maybe he'll try to get a mobile. Maybe if he's paying something 3,000 rupees extra, later he don't want to regret for the decision what he had made. He can just get it something like here. Right, so because something he done a research here, now others are trying to give him some good data, or even he's trying to get some other details from you watching some YouTube, uh, reviews or advertisements. So it's just trying to compare, and finally he's just trying to decide between 20 to 25 because of this collecting this complete data. If he's going this side, it means that he has gone too much with respect to his expectation. So less data to the right hand side beyond whatever he's expecting, and more data between this particular range. So normal distribution will help us to understand whether we have collected the complete data or not. Got my point? Fine, wonderful. So now let me get into, so if this is clear, then let us understand the skewness part. All right, so let me erase this. Today's session is going to be theoretical itself. So I'll be showing you one script to understand the difference between standard distribution and normal distribution, but that will be a little bit challenging to understand. Not sure how many of you are going to take it, but let's get into that. See this. Now, instead of having this kind of curve, instead of having this kind of curve. All right, so now let's say here I'm having mm, let me pick up maybe Mohammed. All right, let's say Mohammed I'm able to have. Now Mohammed is from a healthcare industry. All right, Mohammed is a healthcare person, and he wanted to hand over this particular project to Harsh, who's a data scientist. Harsh is a data scientist. And what he's just saying is nothing but Mohammed is facing one problem. That is nothing but most of the people during this pandemic time and everything. Now, since we are trying to make a machine to predict whether we are having COVID or not, right? Which you all most of the healthcare industries is running with respect to machines. Machine need to properly work. So now, Mohammed, being a healthcare domain person, now Mohammed is asking one question to Harsh. Hey Harsh, we are having a mission. So can you just feed one intelligence to a mission? It's all about artificial intelligence. Can you feed one intelligence to a mission that I will be telling you how exactly this should work? It's because as I know how exactly to differentiate between whether a person is having COVID or not. Let's say I'm having this kind of mission. Where exactly if a patient comes and gives his hand over here, all right? If they're just giving their hand on top of this, now this machine need to say whether this person is having COVID or not COVID. As a doctor, I can say by looking into some readings, temperature and everything, I can say whether a person is having COVID or not by looking into several factors. Let's say age factor and his temperature, body temperature, pressure level. I can say that. So now I will be giving you this kind of data. I will be giving you some age, pressure level, some data, and also I'll just give you the output also. That is yes or no. Yes or no, nothing but he should be having COVID. He's not having COVID in this way. Some data I'll be giving you. Now you just wanted to make a machine learn this kind of pattern to make this kind of prediction. Now later when I'm just giving this pattern, machine need to say yes or no. That's what the business case is all about. Now Harsh got this data from Mohammed. Now what is happening here? When Harsh is performing the data distribution, means he wanted to understand how exactly the data is. Now he's using this data visualization. In yesterday's session, I spoke about data visualization. We can use it for data quality check also. Now here we are having something called as age feature. So he wanted to understand age distribution. So for age distribution, we look into which plot? Age distribution. Y-axis speak about frequency. To understand age distribution, we will look into which plot? Once think on it. Which plot? It's a bell curve. Wonderful, Harsh. Histogram, right? So histogram will help us to understand whether my data is normally distributed or not normally distributed. Now here I'm having some ages like 1, 10, 20, 30, 40, 50, 60, 70, 80, 90. All right. Now let's say your data is like this. All right. So what exactly this one means is nothing but you're having more data. All right. Maybe let me try to take it this way. All right. Which means that you're having more data between ages of 1 to 20. Maybe we can include also 20 or 1 to 15, we can say. 1 to 15, you're having more data. And beyond 20, let's say beyond 20, you're having very less amount of data. So if that is the case, what might be the problem? What is the expected problem that we can see? What is the expected problem? If I'm having more data, less than 20 years of age, and less data after 20 years of age, what this machine will do? The machine is going to correctly predict the age between 10 to 20, and it will do a lot of misclassification between beyond 30 years of ages. Got my point? Here it is going to do a lot of misclassifications. Here it is going to do correct classifications. Yes or no? What do you say? Able to understand this point? Yes. Even if you think us, let's say we are spending artificial intelligence 10 days, we are spending machine learning only 1 day. I said we are going to spend only 1 day. So you're going to gain more confidence on deep learning or machine learning. You're going to have more confidence when you're facing some interviews and everything. You're going to have more confidence on deep learning or machine learning. Deep learning. Why deep learning? Why deep learning? Skewness towards deep learning. Is it skewness towards deep learning? Because we spend more time with it. I'm not expecting some technical terms, just normal terms. So we spend more time, so we have more knowledge about it. All right, Srisha, wonderful. So Pawan is spending time. So that's what it is more important, right? So the point here is nothing but when we are able to spend more time with respect to one specific subject, we try to gain more stability. When we don't spend more time over there, so we try to gain very less amount of knowledge. So the same thing applies over here. So if there is a skewness in your data set, it ends with misclassification. All right, I will be doing a lot of misclassification in my data set. So this particular part, if you see, this is called as skewness. All right, we call this as skewness. And when you look at the tail is towards right side. So we call it as right skewness, or we call it as positive skewness. All right, right skewness or positive skewness. So we look at the tail of the distribution and we try to arrive at the result. Now the straight opposite case, let me erase this. The straight opposite case, what exactly it is? The straight opposite case. So if you look at it, so here I'm able to have ages between 80 to 100. Already here 70 and 70, 60, 50 and everything. So here you're having more data between 80 to 90. So my model, when I'm just coming with the model, this is going to do correct classification between 80 to 90 and more misclassification between 0 to 70, isn't it? So this kind of distribution, we call it as left skewness, or we call it as negative skewness. So skewness, anyway, skewness at the end of the day, it is going to be a problem for my data set. So if the data, if it is normally distributed, then we can come to the conclusion that we have collected complete data. If there is a skewness in my data set, it is going to be a big problem. But if that is the right case, maybe we have to check with Mohammed. So after looking into this, I need to give a call to Mohammed stating that, hey, Mohammed, I performed this data quality check on this age, and I could find that most of the people are coming in your hospital or visiting your hospital between 80 to 90, 80 to 100. Is it right or wrong? If he says yes, then we are good to go and build the model, because we have to educate him. So very less people are visiting between 10 years, 20, 30 years and less than 70. Even the doctor also, Mohammed also knows about it, right? So if he agrees for that, yes, we are good to go. And in case if he's saying that, hey, no, it is not true, then we have to demand more data from the client side or from the doctor. Always we don't try to take a burden on our head. We can demand more data from the client side also, in case if that is the thing. So that's what the fourth point, if you see with respect to data visualization, I mentioned this data visualization can also be used for performing data quality check. So by looking into the histogram, we are understanding the quality of this age, which is one of the feature in my data set. And we can speak to the client stating, or we can demand more data from the client by performing this data quality check. Able to understand this? All right. Yes, understood. Wonderful. So now we discussed about what is this normal distribution, skewness, and everything. Now, how exactly we have, why we need to look into the central value, kurtosis, everything we looked at it. So now the last part is nothing but kurtosis. What exactly is this kurtosis? For that, I used to refer one blog to all of my learners. So the same blog I will be giving you. But before that, do you want to go for 3 minutes break or shall I continue? You want to go for 3 minutes break or shall I continue? Break? As it is a theory. Okay, 3 minutes. Okay, fine. So let's go for 3 minutes break then. So now the time is 8:18. I think more responses. Majority wins as usual. So let's go for 3 minutes break. Let me start the timer here. All right. So now the time is 8:18. We will resume at 8:21. All right. Let me be mute. Hi everyone. It's all back from break. Jyoti, Nabila. Yes. All right. Fine. So let's continue this. So to understand this, Govind, yes, wonderful. So now to understand this kurtosis, so I'll just refer this particular block to you all. You can just take a quick walkthrough on this. Even I think I mentioned the same thing here also. 1 minute. I'll just send you the link. You can later go through and read it. Okay. Fine. So let's go through that. So I'll just highlight some important terms here. So skewness, if you read it, skewness is nothing but it is a degree of distortion. So how exactly from the central value it is getting distorted. So we are having two types, positive and negative. You can take a read on it. So when there is no skewness, my mean will be equal to median. When there is a positive skewness, all right, let me stop sharing it and let me ask this question. When there is a positive skewness, just think about it or think for a minute. When there is a positive skewness in my data, that is when the tail if it is towards the right, your mean will be greater than median or less than median. Once think on it, you can draw your normal distribution, mention some numbers in your x-axis and try to answer this question. You can take 1 minute or 2 minutes. When the tail if it is towards right, the mean will be greater than median or less than median. Just take a paper and write down the numbers in x-axis. And if you have well understood about mean and median, you should be good with that. Harsh, once check it out. Nabila, again, try to take a paper and write it. Jagadish, perfect. Dr. Leela, again, just try to take a pen and paper and understand. Srisha, try to take a pen and paper and write it down. Jyoti, perfect. Let me help you to understand that. Maybe, is it equal, Yusuf? If it is equal, then it becomes normal distribution. If mean and median are equal, then it becomes a normal distribution. See this? All right. So here, let me take 1, 10, 15, 20, 25, 30, 45. All right. So the central value, mean is nothing but what? Simple average. When you just sum it, the mean will be coming somewhere around this particular part. Central value, right? Mean. My median is nothing but what? I'll arrange the numbers in an ascending order or descending order. So the middle value. The middle value will be coming somewhere around here, median. Because it's an outlier basically. So I'm not going to get outlier in median. So my mean will be greater than median in right skewness. Got my point, everyone? Nabila got it, Jyoti. All right. What about left skewness? Mean versus median. How exactly it will be? For left skewness, mean will be less than right. Mean will be less than median. Wonderful, great. So if mean is equal to median, I think everybody got it. If mean is equal to median, then it becomes normal distribution. That's it. So these are all the properties that we have to keep it in our mind. All right. Fine. So there is, and before we get into this, okay, let's complete this and we'll get in. There is one property whenever we are saying that data is normally distributed, it follows one property called as, empirical rule. All right. It follows one property called as empirical rule. You can just note it down. Empirical rule is nothing but 68, otherwise we call it 68, 95, 99.9 percentage rule. All right, empirical rule is also called as 68, 95, 99.9 percentage rule. Now, what is this? We will come back we will arrive at this particular point after some time, but let's get into this. Let's understand kurtosis, and we will compare. We will just be we will be back here. Okay. So now kurtosis is nothing but, see this. Kurtosis, if you read, kurtosis is, it is actually the measure of outliers present in the data. If there is higher kurtosis, it is again going to be a problem. Low kurtosis is again going to be a problem. What is the acceptance point? If kurtosis, if it is greater than 3, it is going to, which means that I'm having more number of outliers. If kurtosis, if it is less than 3, I'm having less number of outliers. That's what this point. Now, later you can just get into this leptokurtic term and platyokurtic. We don't mention it often. We don't need it. Maybe just for terminologies, you can just know it. Mesokurtic is nothing but a normal distribution. Now, what exactly this kurtosis? If you read it here, kurtosis is all about tails of the distribution. It is not the peakiness or the flatness. It is actually the measure of outliers present in the data. Behind this particular kurtosis, there is a mathematical calculation. So I'm not going to get into the mathematical calculation of kurtosis, but now I'm just going to open up one Jupyter notebook just to make you understand how exactly this kurtosis will work. Kurtosis versus skewness. And also if you say skewness, because we can't all the time, we can't expect a bell curve, right? So there will be, if it is a bell curve, then there is no randomness, mean and median. There is no randoms at all. Everything is equal. So if the skewness, if it is between -5 to +5, for negative skewness, -5 to -5, for positive skewness, 0.5, the data is fairly symmetrical, we can say. If the skewness, if it is between -1 to -0.5, negatively skewed, 0.5 to 1, positive skewed, the data is moderately skewed. So less than -1 and greater than 1, the data are highly skewed, which is totally, which is not acceptable, we can say, or there is more skewness in my data, which will impact in more misclassification. That's what this point. So now what I'll do, let me open up one Jupyter notebook. There is a lot of mathematical calculation how to do skewness and kurtosis, but now since we are relying on this Python, let me help you to show how to calculate with Python. Let me get into it. This material is just for understanding purpose. Okay, so all right. Now see this. I'm not executing anything, but if you see this particular part, let me explain this. So I'm not explaining this particular data set, but just see, you're having few features: type, air temperature, process temperature, rotation speed, torque, This is just one data set which has been worked as, which is nothing but one particular project. It is a predictive maintenance project, which is basically given by ExcelR to a project team. And this data set, I'm not sharing it, but I'm just using it so that you can just understand it. So here, I'm just going to take only one column. That is, here we are having torque Newton meter. Okay, here we are having this particular column. Now I want to understand how exactly, whether this torque Newton meter, is it normally distributed or not, I want to understand. So for that reason, I'm going to use this histogram to understand it. All right, now see this. Now even you can just do it. So here, if you look at the dots, if you're just giving it dot, you're just picking up this one particular column. And if you give dot and if you give tab button, you will be seeing list of functions. So you can just choose to see this. You can choose, you're having kurtosis as one of the function. Kurtosis and kurt is nothing but the same thing. And if you scroll down, you'll be seeing skewness. Skew. All right. Let me click on skew, which is a function. Let me shift enter if I'm giving it. minus 0.09, which means that what? If you're rounding it, skewness is 0. If skewness is 0, then it becomes normal distribution, or what is it, a skew data? If skewness is 0, is it positive skew or left skew or normal distribution? Normal distribution. Great. Now if you see maintenance data, let me pick up the same torque column dot kurtosis. What do you think the kurtosis will be? The kurtosis, if you look onto it, the kurtosis value, will it be greater than, you can just see this, will it be greater than 3 or less than 3? What do you see? Will it be greater than 3 or less than 3? I'm not executing it, but I'm just expecting an answer. Will it be greater than 3 or less than 3? Less than 3. Equal to 3, Jyoti, there is some mistake over there. That is not something right there. That's just, you have to correct it. See this? It is equal to 0. So the point is, if skewness and kurtosis, if it is equal to 0, now if you look onto this distribution, I think I've already performed this distribution. 1 minute. Abhijit, you will be getting it. Abhijit, wait for a while. You can focus on the session. Later, you'll be getting the attendance links and everything. So now I'm just using this PLT dot torque. So now if you see, my data is normally distributed. All right. Even there is another plot also within a C1. You're having another plot called as dist plot, where exactly, if I'm just able to give it, I will be able to see this kind of bell curve. So now the center point is 40. Bell curve I'm able to see. So now if it is a bell curve, normal distribution, why it is symmetry? If you see from the center point, I'm able to have 50% to the left hand side, 50% to the left hand side, and 50% to the right hand side. Both things are pretty equal, right? So we call this normal distribution as bell curve. And now here I can just say the data is completely collected with respect to torque. Now able to understand how exactly normal distribution is working. Skewness, kurtosis. Perfect. Now let me show you some other data set. See this? Here, this is another data. Again, I'm not getting into it. Just see this. This is a machine learning problem statement. Here, just imagine the client had given you this data set. CRIM, ZN, Indus, and everything. You're having more features. Now what I'm doing? Now I'm just picking up this Indus. Is it normally distributed? Is this data Indus? Is it normally distributed? No, it is not normally distributed. All right. Let me do this. It is not normally distributed. So now what I'll do, let me execute it. I just wanted to see this skewness and everything. Just once think on it and you can give me the figure. Okay, let me pick up some other column, maybe EZ, and let me pick up. Don't try to understand the script, whatever I've written it, that you will mislead, but just you want to understand the concept. That's it. So this one, is it normally distributed? What type of distribution it is? What type of distribution it is? Positive skewness. So if I'm just calculating skewness for this, it will be greater than, again, look onto this material. Will it be between minus, anyway, it is positive, right? Will it be less than 0.5 or less than 1 or greater than 1? It is, anyway, it is a positive. So will it be less than 0.5 or less than 1 or greater than 1? What do you say? What do you say? All right. I think everybody got it. It is definitely greater than 1. Let's try to calculate it. House details. Let me pick up this ZN. Dot skew. See this? 2.22, which means that it is greater than 1. So I'm having the skewness is pretty high towards the right hand side. So if there is this kind of skewness, my model will not be able to do the right prediction. Now we have to check on it, why it is something skewed towards right hand side. All right. Now let's calculate the measure of outliers. That is kurtosis. Zn dot kurtosis. I'm going to do that. Now dot kurtosis. Will it be less than 3 or greater than 3? Trisha, wonderful. Kurtosis, will it be greater than 3 or less than 3, the measure of outliers? Greater than 3. See this. It is 4.03, which is nothing but it is greater than 3. Again, more number of outliers towards the right hand side. So again, within that, I'm having mathematical equation. You can just try reading it. What is the mathematical equation? How we are calculating the skewness and everything. But I'm just trying to focus on the deliverables. What is how you have to interpret it? That's what I'm just trying to focus here. The mathematical calculations and everything, you can just try reading it, some blocks or whatever. But what is the takeaway? How you have to understand from this result? That's what I'm just focusing here with respect to this session. Okay. Now I think you are good with this respect to the skewness and kurtosis. Now, the time is 8:40. Let's try to understand the difference between normal distribution. As I said before, normal distribution, one property I mentioned there. What is the property of a normal distribution? What is the property I mentioned? If I'm saying it is a normal distribution, it follows one property. What is it? Symmetrical. That is, it follows area under the normal distribution is 1. Yes, someone, which is used for probability distribution, right? So whenever I'm saying it is a normal distribution, it follows one property called as empirical rule, right? That we can just, 50% to the left-hand side and everything, a lot of things. I mentioned this term, it follows empirical rule. Empirical rule is nothing but 68%, 95%, 99.99%. So to understand that, what I'm doing, see this, I'm just calculating a mean, that particular torque. Now I'm just coming back to this torque Newton meter, what I just picked up. Mean, I'm just calculating it, 39.98. So this is my central value. And I'm just picking up the standard deviation. All right. So now what is the theory is nothing but, I'm just not looking into the chat box for a while. So when I'm saying a normal distribution, it follows that empirical rule. 1 minute. Sorry, I'm not. All right. So now the central value is nothing but mean. We call it as mu. What is that mu? 39.98. So mu is equal to 39.98. Now here we can say it is -1 standard deviation plus 1 standard deviation. Now we have to find out what is the value for -1 standard deviation plus 1 standard deviation. Now for 1 standard deviation, we got it 9.96. All right. Now what I'm doing for calculating -1 standard deviation, this can be measured as from the central value -1 standard deviation we have to calculate. So what I'm doing, maintenance torque data dot mean minus 1 multiplied by maintenance data dot standard deviation, it is 30.01. So this value is nothing but 30.91. 30.01, sorry. Now the right hand side, this value I would just want to calculate. The right hand side value, what is it? Just have to replace by plus. Let me do this plus. It is coming around 49.95. Now here this values what I'm doing here, if I'm just saying it, it is mu plus 1 standard deviation. It is coming around 49.95. Now within this particular value, that is when torque Newton meter between 30.01 and 49, I think 49 points this. When I'm filtering this particular data, 68% of the data should fall between this particular thing. All right. So that's what this normal distribution rule. Now within this, 68% of the total observation should fall under. So the total observation size is 10,000. Out of 10,000, what is 68% size? 68% is 6,800, right? So 6,800 observation need to fall between this particular range, 30 to 31. So for this, what I'm doing, I'm just doing one filtration. That is maintenance data greater than 30.01 and less than 49.95. The total, so only this part I'm just doing a filtration. So if I'm doing it, the total observation size, it should be 6,800. So 68% of the total values, when I'm just going for the filtering with respect to torque value, which falls under 1 standard deviation. Now what I wanted, 2 standard deviation. 2 standard deviation is nothing but again a bell curve. Now we got this mu, 1 standard deviation we got it, -1 +1. Now within this 2 standard deviation, I just want 95% of the total values should fall between 2 standard deviation. Now here, what is the 2 standard deviation for thing? Mu minus 2 standard deviation. So what I'm doing, mean minus 2 multiplied by standard deviation if I'm giving it 20.09. So here mu plus, that is a mean plus standard deviation if I'm doing it 59.9. So if I'm just doing it plus, now I got this 59.992, which is nothing but the value. Now I'm just getting it. Now what is the range? 20 to 59. I'm expecting totally 95% of the observation should fall between this particular range. So now what I'm doing, 95% of the total values should fall between this particular range. So I got it. Now 3 standard deviation. Within 3 standard deviation, again mu minus 1 standard deviation, you got it. 2 standard deviation, you got it. 3 standard deviation, I'm expecting 99.99%. So what I'm doing, minus 3 multiplied by standard deviation, 10.08, plus 3 multiplied by standard deviation, 69.89. So between this particular range, I'm expecting 99.99%. So when I'm doing this particular filtering, 10.08, I'm just giving it here. And greater than this particular one, 69, I'm giving it here. Totally, I'm expecting 99.97. So torque follows this normal distribution. So we don't need to check for all this mathematically whether it is following this or not. Just to make you understand how exactly, what is the property of empirical rule, what is that 68%, 95%, 99.99% rule. I have done this particular calculation. Other than this, you don't need to see anything. So just if you're looking into this particular bell curve, this is more than sufficient for us to come to the conclusion that is whether the data is following normal distribution or not. Other than the calculations, whatever I've shown you here, just to make you understand the rule of 68, 95, 99.99. What exactly we are saying? We are expecting within 1 standard deviation, we are expecting 68% of the total value should fall between this. Within 2 standard deviation, we are expecting 95.99. Within 3 standard deviation, we're expecting we are this value. Other than that, we call it as outlier points. We try to ignore them. Okay. So this is how this normal distribution will work. Is this point clear? Empirical rule. Below, Chaitanya said confidence interval limits. No, I'm not speaking about any confidence interval here, Chaitanya. That is different subject. I'm speaking about standard deviation. All right. So this subject, and again, there is one more thing called a standard normal distribution. I'm not getting into it, but I just wanted to give a try today. Try understanding the difference between normal distribution versus standard normal distribution. Try doing your own research, come back Monday. I would expect you to give a good response on next Monday. Normal distribution versus standard normal distribution. Do your own research, come back Monday. In case if you're giving some responses, I will be explaining it on next Monday. All right. Standard normal distribution. Normal distribution versus standard normal distribution. I think Dr. Leela is saying the correct numbers. 3 sigma, it is 99.7, 6 sigma, it is 99.99. All right. Fine. So that is all about this particular session. It's more about theory. Amol, for standard normal distribution, mean is 0, variance is 1. Great, Amol, you got it. Anyway, try doing your research and come back next Monday. Try to give your responses. We will see how exactly it goes. All right. So today we discussed about statistics. We started from why we need statistics, and we understood about why we need to get into sample, why we can't get population all the time. And then we compared sample versus population. And then we discussed about for sample collection, we need domain knowledge. And then we discussed about from population, we are collecting some set of sample, and we are performing some exploratory data analysis on sample. And within, to understand the sample more, we are performing measures of central tendency, measures of dispersion, normal distribution, skewness, and kurtosis. So within measures of central tendency, we are having mean, median, and mode. How to choose between mean, median, and mode, we learned it. And again, within measures of dispersion, we learned about variance, standard deviation, and range. How to choose between one, why we are always relying on standard deviation, we learned it. And then we discussed about normal distribution. What is this normal distribution signifies? What is its importance, and how exactly it would work? And why we are expecting a normal distribution all the time? We learned it. And what are all the other terms of normal distribution we learned? That is Gaussian distribution, symmetrical around the mean, and so this is what we learned it. And then it's all about, it will give us an assurance that we have collected the complete data. In case of the data, if it is not normally distributed, what are all the impact it will do? In case if it is skewness towards right, it will do a lot of misclassifications. And if it is a lot of outliers, Kurtosis is all about outliers. If there is more outliers in my data, I will miss the stability, because more outliers, it will mislead to stability of my results. So that's what this Kurtosis is all about. So, and we looked on to that, what is the decent kurtosis that we are trying to accept? What is the decent or fair amount of skewness that we are trying to accept? We learned it. And then we discussed about that empirical rule, 68%, 95%, and 99.7 or 9%, we discussed it. And then we are winding up the session now. All right, maybe you can just take this link, just go through it. I'll just paste this link on the chat box, or even you can find this link on internet or so, we can get it. All right. Great, Dr. Vera, yes. All right, Vera, thank you. Fine then, so hope we are good with today's session. Let's be back by next Monday, and we can continue the session 2 there. And next Monday, we'll be working with some script, as I said, a random variable and probabilities. That is a topic for next Monday, which will be getting into more scripting and everything. All right. Take care, everyone. Hope you had a great session this week, all Monday to Friday. Python session and Python libraries and the statistics. Let's be back by Monday and we can continue it. All right.